All right, so we are back. I want you all to pause the video and try this question and resume for the solution. So the question tells us one root of x square plus kx minus 8 is square of the other. So if I call, let's say, one root as alpha, the other root will be alpha square, right? Then what is the value of k? Okay, interesting question. Now, guys, we know that for any quadratic equation of the type ax square plus bx plus c is 0, the sum of the roots is always equal to minus coefficient of x upon coefficient of x square. So in this case, the sum of the roots alpha plus alpha square will be minus b by a. And in this particular question, b is worth k. So I will have minus k and a is worth 1 here. The coefficient of x square is 1. So I get alpha plus alpha square is equal to minus k. Similarly, for the same quadratic equation, ax square plus bx plus c is 0. We know that the product of roots is always equal to constant term upon coefficient of x square. So the product of the roots alpha into alpha square is constant term upon the coefficient of x square. It is equal to c by a. Now, in this question, c is worth minus 8 and a, as you already know, is 1. So alpha into alpha square is alpha cube will be equal to minus of 8 upon 1, or alpha cube is equal to minus 8. If alpha cube is minus 8, if I take cube roots on both sides, guys, I'm going to get alpha is equal to cube root of minus 8, that is minus 2. Is there any other value possible for alpha? Let me know into the comments. So we take value of alpha, it is minus 2, and put that in this given expression. Alpha is minus 2 plus alpha square will be minus 2 square is equal to minus k. Minus 2 is as it is, plus minus 2 square will be 4 is equal to minus k. Minus 2 plus 4 is worth 2 only. If 2 is worth minus k, obviously k will be worth minus 2. And that is the answer to my question. Option D, k is worth minus 2. Simple question. That's how we solve it. Please try this next question. So once I had been to the post office to buy stamps of 5 rupees, 2 rupees, and 1 rupee. So 5 rupee stamps, 2 rupee stamps, and 1 rupee stamps. I paid the clerk rupees 20, and since he did not have any change, he gave me 3 more stamps of 1 rupee. If the number of stamps of each type I had ordered initially was more than 1, what was the total number of stamps that I had bought? Interesting question and a very sweet and simple question. Let's see how we deal with this. The last line is the breakthrough we need in this question. The number of stamps of each type I ordered initially was more than 1. More than 1 means at least 2. That means 5 rupee stamps, 2 rupee stamps, and 1 rupee stamps. There were at least 2 in number. They were at least 2 in number. So 2 stamps of 5 rupees, I have accounted for 10 rupees. 2 stamps of 2 rupees, I have accounted for 4 rupees. And 2 stamps of 1 rupee, I have accounted for 2 rupees. So 2 plus 4 plus 2 should be equal to rupees 16. So we have already accounted for rupees 16 here. But the question says the clerk did not have any change and he gave him 3 more stamps of 1 rupee, right? So now he had 3 more stamps of 1 rupee. That accounts for 3 more rupees. So 16 plus 3 rupees would account for rupees 19 in total. But as per the question, the person paid the clerk rupees 20. But here I'm getting a sum of only 19. That means the 1 rupee stamps that he had bought were not 2 in number, they were actually 3. Such that the total value here won't be 2 rupees, but it will be 3. And here I won't have 16 rupees, I will have 17 rupees. And now 17 plus 3 accounts for a total of rupees 20 as we require. So what was the total number of stamps that the person had bought? The person had bought 2 stamps of 5 rupees, 2 stamps of 2 rupees, 3 stamps of 1 rupee. That gives me a total of 2 plus 2 plus 3, and that is 7. But since that does not match with the options, we obviously have to add these 3 stamps that the clerk gave him. 7 plus 3, the total number of stamps bought was rupees 10, and that is naturally your A option. Okay, I'm presuming that we have to include those 3 stamps. Otherwise, the logical answer would be 7 in this case, the stamps that he had bought. But since he has 3 stamps extra, I think the answer expected here is 7 plus 3, that is 10. And that's the A option. So given the quadratic equation x square minus a minus 3 into x minus a minus 7, for what value of a will the sum of the squares of the roots be 0? All right. So once again, we use the same concept of roots of a quadratic equation. For any quadratic equation of the type ax square plus bx plus c is 0, the sum of the roots is minus b by a. We know this. And the product of the roots is basically c by a, right? Sum of the roots is minus b upon a. B in this case is minus of a minus 3. You can observe it. So sum of the roots is minus of minus a minus 3 divided by coefficient of x square is 1. So for this quadratic equation, sum of the roots is simply a minus 3. Similarly, we know product of roots is c by a, the constant term upon the coefficient of x square. Constant term is minus of a minus 7 and the coefficient of x square is 1. So the product of the roots is minus of a minus 7. I can also call this as 7 minus a, right? Now we want to find out the sum of the squares of the roots, right? And sum of the squares of the roots will be alpha square plus beta square. Let's call this as suppose k. And now I simply add 2ab on both sides. You will very soon understand why. Let's add a 2ab on both sides. Remember, I want to figure out the value of k here. I'll just add 2ab, that is 2 alpha beta on both sides. Now my left-hand side is of the form alpha square plus 2 alpha beta plus beta square. This is alpha plus beta the whole square, right? Is equal to k plus 2 alpha beta. Take this 2 alpha beta on the left-hand side. You'll get k as alpha plus beta the whole square minus 2 alpha beta. And that's all. Now we simply need to plug in the values here. Alpha plus beta the whole square. In place of alpha plus beta, I'm going to substitute a minus 3. So it will be a minus 3 the whole square minus twice of alpha beta. Alpha beta is 7 minus a. And this is worth k, but k has been given to us as 0. The sum of the squares of the roots is 0. So k is nothing but 0 in this case. I simply need to solve for this equation and find out the value of a. I'll solve it here. Open out the bracket a minus 3 the whole square. A square minus 6a plus 9 minus twice of 7 is minus 14 and minus 2 into minus a is plus 2a and this should be equal to 0. Okay, so I can now write this equation as a square minus 6a plus 2a is minus 4a and 9 minus 14 is minus 5 is 0. This is a quadratic equation. You want sum of two numbers as minus 4 and product is minus 5. The numbers are minus 5 and plus 1. So a minus 5 into a plus 1 is 0. That gives me the value of a as either 5 or minus 1. And that's the answer to my question. A is either 5 or a is minus 1. And I think the option that perfectly matches is the D1. None of these. And that's the answer here. 5 or minus 1. That is very clearly option D. So which of the following values of x do not satisfy the inequality x square minus 3x plus 2 greater than 0? Okay. So the first step is we factorize this quadratic. X square minus 3x plus 2 is greater than 0. Now, x square minus 3x plus 2. We want two numbers whose sum is minus 3 and product is plus 2. They are minus 2 and minus 1, right? So this quadratic equation can be further split as x minus 2 into x minus 1. And now you want this product to be greater than 0. And now the product of two terms should be positive. This can happen in two ways. First, when both of them are positive. So x minus 2 is greater than 0 and x minus 1 is greater than 0. Also, when both are negative. So x minus 2 is less than 0 and x minus 1 is also less than 0. In the first case, x should be greater than 2 as well as x is greater than 1. For both of them to be simultaneously true, I have to consider x greater than 2. Similarly, if x minus 2 is less than 0, x is less than 2, and x minus 1 is less than 0, x has to be less than 1. For both of them to be simultaneously true, x has to be strictly less than 1, right? That satisfies both the conditions. So my final answer is x is greater than 2 or x is less than 1. And that means x cannot be lying in between the two, meaning x cannot be greater than or equal to 1 or less than or equal to 2. Right? X cannot lie in between. So directly we can eliminate the A option in this case. A option will not satisfy the given condition. Since x is more than 2 and less than 1, X can't be greater than equal to 1 or less than equal to 2. It is very clearly our A option, and that's the answer to your question. You can revise the concept of inequalities from our course. I have given the link in the description as well. You can check it out. All right, please give this one a try. All right, so out of 2/3 of the total number of basketball matches, a team has won 17 matches and lost 3 of them. What is the maximum number of matches that the team can lose and still win 3/4 of the total number of matches? If it is true that no match can end in a tie. No match can end in a tie. No match can end in a tie would mean that every match has a decisive winner. The question is, what is the maximum number of matches that the team can lose and still win 3/4 of the total number of matches? Now, the total number of matches are 30. So 3/4 of that would be 90 by 4, roughly 22.5. Right? So the team wants 22.5 victories. Out of them, they have already had 17 victories. So now the team wants 22.5 minus 17. Balance 5.5 victories. Okay, well, the number of victories obviously can't be in points. So we take it as 6. So the team now wants 6 victories. So out of 10 matches remaining, 6 matches will be victories. How many will be the losses? 4 matches will be the losses. They're asking you, what is the maximum number of matches that the team can lose? The answer would be 4 more matches. It is your A option. Simple question. That's how we solve it. The answer is option A, 4 matches. Right. So it's super easy one. If the roots x1 and x2 of the quadratic equation also satisfy the equation 7x2 minus 4x1 equal to 47, then which of the following is true? Okay, the equation here is of the form ax square plus bx plus c. It's a quadratic. And guys, for quadratic equations, we know the sum of the roots is minus the coefficient of x upon the coefficient of x square. So if the roots are x1 and x2, the sum of these two roots, x1 plus x2, will be minus b by a. Okay, b here is minus 2. So minus of b will be minus of minus 2. And coefficient of x square here is 1. So a here is 1. From here, I will get x1 plus x2 is equal to minus of minus 2 upon 1. That is 2. We have also been given 7x2 minus 4x1 is 47. Right? So we have two linear equations. We can now solve them simultaneously. If I multiply the first equation with 4, I will have 4x1 plus 4x2 is 4 2s are 8. And the next step is I'm going to add these two equations. Minus 4x1 and plus 4x1 cancels out. 7x2 and plus 4x2 will be 11x2 is equal to 47 and 8 is worth 55. Dividing by 11 on both sides, x2 will be 5. If x2 is 5, we put it here. x1 will be equal to 5 plus x1 is 2. x1 is 2 minus 5, that is minus 3. So x2 is worth 5 and x1 is worth minus 3. Now, guys, we know that sum of the roots for a quadratic is minus b by a. Similarly, the product of the roots will always be equal to c by a. The constant term c upon the coefficient of x square, that is a. The constant term c being equal to c in the question and a is equal to 1 here. So product of the roots x1 into x2 should be c upon 1 or simply c. x1 we have found as minus 3 and x2 we have found as 5. So C will be minus 3 into plus 5, that is minus 15. C is worth minus 15. X1 and X2 are minus 3 and 5 respectively. So options B and C are ruled out. A we have found is true. So yes, only A option is true. The answer to your question. Okay, so 1 year payment to a servant is rupees 90 plus 1 turban. The servant leaves after 9 months and receives rupees 65 and a turban. Then find the price of the turban. Let the price of the turban be equal to T rupees. So the servant was supposed to be paid rupees 90 plus the turban of T rupees. This was the total payment for 1 year. And 1 year corresponds to 12 months. From here, I can find out his monthly payment. His monthly payment would be 90 plus T divided by 12. Like this, the servant leaves after 9 months. So the amount he's supposed to get is this 90 plus t upon 12 multiplied by 9. And the question says, after 9 months, he receives rupees 65 and a turban. Turban is worth t rupees. So 90 plus t upon 12 into 9 is 65 plus t. You can solve this equation to get your answer for t, the price of the turban. We can cancel out 3 here, 4 remains, 3 here, 3 remains. Take 4 on the right hand side. You will have 3 into 90, 270, plus 3 into t, that's 3t, is equal to 4 into 65. 4 here, 4 into 65 is 260, plus 4 into t, that is 4t. 270 plus 3t is 260 plus 4t. Solving this equation, 260 on the left hand side and 3t on the right hand side, I would get 270 minus 260, 10 rupees. 4t minus 3t as t rupees, we get t as 10. So the price of the turban is option A, rupees 10. Very simple question. All right, please solve this question, guys, and then you can resume for the solution. So the question tells me the expenses of a boarding school depends upon the fixed cost and the variable cost. Variable cost varies directly as the number of students. So there's a fixed cost, let's call that as rupees K, and variable cost, let's call that as rupees X. X rupees per student. So what is the total expense of the boarding school? The total expenses would be the fixed cost K plus number of students N multiplied by the variable cost X. So now remember, these expenses are the total expenses of the boarding school, right? That means if the expense per student was rupees 600 for 50 students, the total expense would be 600 multiplied by 50, and that is 30,000, which is nothing but the fixed cost plus number of students here is 50 into X, 17,500 rupees. And that is the fixed cost K plus 25 students into X. The next step is I subtract these two equations. Okay, equation 1 and equation 2. I subtract the two and I'll get a new equation that states K cancels. 50x minus 25x would be 25x. 25x would be 30,000 minus 17,500, 12,500, right? And from here on, I have two ways of answering the question. Okay, I can either treat this as the situation of two equations and two variables. 25x, if I substitute in any of these two equations, I will get the value of K. Let's put that in the second equation. I'll get 17,500 is equal to K plus 12,500. Subtracting 12,500 from both sides, I get K as 17,500 minus 12,500. That's 5,000. And that's it. Once we have found the value of K, and we have also found the value of X, like from this equation, dividing by 25 on both sides, X is basically 500. Once we have got the value of K as 5,000 and X as 500, we can very easily calculate the total expenses for 100 students. That will be K, that is 5,000, plus N is 100 into X is 500. 500 into 100 is 50,000 plus 5,000 is 55,000. Right? So after reaching this particular step, 25x is 12,500. This is one way in which we can answer the question. The other way is, if 25x is 12,500, then multiply both sides by 3. You will simply get 12,500 triple is 37,500. Now add the 75x to the second equation. Your right hand side would become k plus 25 plus 75. That is k plus 100x, which is equal to 17,500 plus 37,500 will be simply 55,000. We have actually got the total expenses for 100 students, k plus 100x, and straight away our answer 55,000. A very quick shortcut and gives the answer option D very instantly.